And now we're going to hear from a very esteemed panel assembled by AGS counselor and Columbia professor, Dr. Alex D. Suburban, on global risks and human security. Alex?
All right. It's great to be here, and I think the panelists are waiting for their chairs. So I'll go ahead and get started with a little introduction. So the geospatial revolution of the past several decades has led to increasingly fine-grained spatiotemporal characterizations of human populations, natural hazards, human-induced hazards, and the risks they pose at global, regional, local, and even hyperlocal neighborhood scales. The application of modern GeoAI techniques to continuously improve these assessments of risk to human security has opened up new opportunities to anticipate and prevent human suffering, ecological destruction, and even the climate emergency, which we heard a lot about in the last two Geography 2050s. This session brings together top experts in academia and the geospatial industry to explore how GeoAI can help us better grapple with risks to human security and our planet. And first up, we're going to have Ryan Engstrom, who's a good friend and colleague at George Washington University. He's the director of the Center for Urban and Environmental Research and the Spatial Analysis Lab. He earned his PhD in geography from the joint program between San Diego State and University of California, Santa Barbara. His research interests are in using geospatial techniques, primarily remote sensing, to understand spatial variations in a wide array of issues, including climate change, health, poverty, and population. He's had a wide array of collaborations and funding sources, and so with that, and he's also been very active in youth mappers, which we heard a bit about yesterday. So Ryan, come on up and share with us what you have to say.
Thanks, Alex. It's great to be here. Is there a clicker?
Is there a clicker?
Maybe.
I'll walk across to see if there's a clicker over here. Yes, there is a clicker.
Oh, awesome. Thank you. Yeah, it's great to be here. As you can guess, my colleague Marie Price is always trying to drag me up here to Geography 2050. And this year I really wanted to come because it's been really great to see the GeoAI thing. This is something I've been interested in for a long time in my career. What I'm going to talk about today is a project I've been working on, and one of the other things I helped found probably about 5 or 6 years ago is this idea of idea maps. And idea maps is this ecosystem of mapping deprived areas. And so I'll give you a little bit of background on this. I'm one small part of this project. It's very international. It's got the Urban Big Data Center at University of Glasgow, myself at George Washington University, University of Twente, University of Lagos in Nigeria, and also some people from Columbia University. And so this is kind of a huge collaboration of work that I'll kind of talk about. And what we're trying to do is to create integrated data ecosystems to routinely map deprived areas. And a lot of times people simply call it slums. It's poor areas that are, have resource limited within cities. It's amazing. You spend a lot of time talking to economists or people in that field, and they go, the cities are rich, the rural areas are poor, and then they don't have any differentiations within the city. Also, UN Habitat is trying to understand SDG 11, going after fair and adequate housing, and there's no standard on how to do this. And so what we've been trying to figure out is there a way we can standardize this? Is there a way we can map it? And a way we can bring people together to do this? And so we're funded by Bill and Melinda Gates Foundation to do this and kind of look at this and take this in. My part in it is to do the remote sensing, the GeoAI, the modeling, and all that source in it. We've been looking at a number of cities. It's been amazing. We were just talking about it backstage a little bit, like all these cities that are super well mapped. They're talking about New York City and all the different layers. You go to these developing world cities, what do they have? Very limited data sets to what to go after. And so what we're trying to do is build these things and then build it together. And one of the big things that really drew me to this project is this kind of diagram that I'm showing right here. Is we're trying to take and create data that's grounded, that's generative, that's impactful. So like, we haven't really, I've seen very little talk about like, what is the impact of making this GeoAI or making these maps? What are they being used for? And this is one of the things that we're trying to really work on, is actually talk to the people. And you meet these people from slum communities and you show them a map of a slum and you go like, here's your slum where you're living, this is how we depict it, and this is why we put it on the map. And so this is a really powerful thing, and it's pretty amazing when you go to these communities and they can look at the map and they know exactly where they are, and they can point themselves out and be able to do this. And so the other thing is, you got to think of the ethics of putting them on the map. Because once you're on the map, then the cities know where you are. And so this is a really thing that we really think about ethically, is like, okay, do you want to be on the map? How well do you want us to put you on the map? And be able to make that decision. And you talk to people and they go, we want to be on the map because we want to be known. We want to get help. We want to advocate for ourselves because they know that they have to do this. And so what happens is we start talking to people like city decision makers, because what happens is you go to these cities and they have really limited data to make decisions on, okay? We can show them a map and be able to do that. And then one of the big things with this map is we'll make a map, we'll do the GeoAI, the fancy modeling, we'll show the people the map and we go, hey, are we right? This is something that we haven't really talked about a lot today, is like, how accurate are these things? And one of the things that's really difficult to map with a slum is, what does a slum look like? There's huge variations on what people believe in it and what's the definition of it. And then one of the big things is UN Habitat defined it at the household level. How do you define it at the area level? And these are all the things that we're going after to be able to do that. And we're trying to bring together the decision makers, the transnational networks, the modelers, the software developers, and be able to do that and talk to the communities. And is it scalable? That's one of the big difficult things. Can you make these maps across cities and across areas? And so when I talk about it, our goals and issues. So scalable, we're trying to make an input and put data sets that are in there that are available everywhere. It's like you've seen this explosion in building footprints. You just saw like a Copia's slide and they were mapping all the building footprints. I remember when that first building footprint from Copia came out for all of Africa, and we were blown away. And then you start to zoom in on it and you look at slum areas and it's usually like one big building or it's missing. And so there's a lot of information that's really difficult, because like even if you sit there, I have youth mappers and I have people map buildings in those areas, the roofs overlap. It's nearly impossible to pull it out. And so it becomes one big blob. How do we represent it? And so one of the things is when we put these things in there, we test different building footprints, road networks, imagery, and then just geospatial data that's now available at the global scale. And so that way you can make a model in one city and see if you can move it to another. One of the things we're finding very difficult is they don't transfer. Is Lagos, Nigeria looks very different than Kano, Nigeria. It doesn't go within countries. Accra is very different than Nairobi, Kenya. And so this is one of the big issues that we're trying to figure out. And so how do we do this if there's not consistency between cities when you make these models? Because that's one of the big things. Some of our issues we're looking at is training data. For the most part, a lot of the people have mapped slums typically, doing a polygon. Well, if you put that polygon into a model and you get any vegetation in there, all of a sudden, when you do a per pixel analysis, all the vegetation becomes part of a slum, and you map the city completely wrong. And you have big issues with that. Typically, you have limited training data to be able to do this. Anybody knows with all these models, it's all about the amount of training data and the quality of that training data going in. And if you have garbage going in, you have garbage coming out. One of the other things we struggle with is class imbalance. If we actually just map the city and we said, hey, we'll skip slums, we'll get like 97% accuracy or 95% accuracy because only 5, 6% of the city is covered by slums. And so it's really tough to be able to map when you're going after these specific things that are very small and a very small percentage of the city. Also, if you change urban density, the slum looks totally different. And this is one of the big things that we start to struggle with is you can have houses like in very tight areas that are overlapping, and then other places that are pretty spread out, but they're still slums. And they look totally different. So how do you start to model this type of stuff? The other point is privacy. You know, at what scale do we put these maps out at? Because we struggle with this. You know, you don't want to get tiny little slums that are just being built because this will impact people and that allows them to get evicted. But then other people want to be on that map because then when somebody comes in to evict them, they can say, hey, we were there at this date. We've been around for a long time. And so when you're talking to these people, you got to understand, you know, what's going on. As you can imagine, with all these different people and all these things making inputs, it becomes a huge question of what is a slum? How do you define it? And it's really difficult to do. And so, you know, when you look at some of these GeoAI examples, like, you know, you typically know what a building is or an airplane is or a car is, and you map these objects. When you're mapping a slum, what is it? It's kind of heterogeneous, and it varies very much within different parts of the city. And almost every time we overpredict. And so we asked people living there, like, would you rather have us overpredict or miss you? And so they were like, hey, overpredict, because then we can always take you out. And so this is the things that we start to talk about, an agreement on what defines a slum. And so one of the things that we're doing, this is just stuff we just did, I think, a few weeks ago, is we're taking like information. We do these things called contextual features from Sentinel-2 imagery. You know, it's global coverage, geospatial covariates, so like all the geospatial layers people make that are available for the entire globe, places like Africa especially. Shape features from roads, shape index. This is all stuff we put into these models to try to make predictions. Also, we do mapping units. Do we do a 100-meter grid cell? We don't want to do individual houses. Do we do street blocks? How do we represent this and go after it? And the thing highlighted here is density strata mapping, and this is what is showing you some of the results that we do with machine learning. Is what we find is actually within cities, if we do really dense areas, those are pretty comparable across cities. If we do less dense area, those are somewhat comparable between cities. And then a medium density for population density. These can be kind of ways to do it. Instead of going city by city, you do like representative variations within a city to make these models and start to progress through. And that's kind of the thinking we're going after right now, in generating these maps and separating these into clusters. And so this just gives you some sort of estimation of what we're able to do. And as we do this, so what we do is we'll produce a map like this. We'll produce a map that covers a city and say like, hey, this is where all the slums are. We then go to people that are working in the city, like the city decision makers, Slum Dwellers International, other different programs. We'll put that in front of them, and then they can decide, hey, is this area a slum or not? And they'll start to map it and tell us if we're right, if we're wrong, and then we reevaluate that and redo the model again. And so this is how we've been building this and going after it. And it's a really interesting project. It is very difficult to get all those people in the same room because what happens is not everybody trusts everybody. And so a lot of times you're sitting there and we kind of back away when the government starts yelling at the slum dwellers and so forth. You start to move away and you're like, okay, let's talk about this and see where they are. And we actually have almost become a place where sometimes we can be that way where people can talk to each other and be free and open to be able to do that. And so this is how we start to take this GeoAI thing and bring it back to the people and be able to do that. But this just gives you some example. And so if you want more information, this is our website. We're open. This is Idea Maps is like a consortium of people who are just interested in doing slum mapping. And so we're open to everybody to be able to be part of it. And if you're interested, let me know. Thank you.
So now moving from the urban to the rural, we're going to hear from Catherine Nakalambe, who is an assistant professor at the University of Maryland and the Africa Program Director under the NASA Harvest Program. Catherine has broad research interests and leads projects focusing on the development of methods and applications of remote sensing and machine learning to agriculture and food security, land use and land cover change, humanitarian mapping and climate change, and has several capacity building initiatives in the use of remote sensing for agriculture. She was the 2020 Africa Food Prize laureate for her dedication to improving the lives of smallholder farmers by using satellite technology, and she's run other awards at the University of Maryland. Catherine, we're really delighted to have you here.
Thanks for having me, Alex. I'm glad to be here, and you can see I put in a lot of effort and made sure that my slides are going along with the theme of the conference. So the graphics might not be very clear, but they're at some point were in color. And most of us have probably seen this graphic before. I think it comes from NASA, and we also know that drought is an old age problem, one that is predictable, one that we can manage quite extensively, one where we have a lot of technology if you're thinking about it in a context of agriculture. So trying to monitor where water is important for managing droughts in California. Looking at snowpack, for example, is important. However, in some places, it's a lot more complex. Even though it's predictable, slow creeping, and we have a lot of technology and knowledge, some of the most earliest technology or utilization of remote sensing had been to understand drought effects over really large areas. So the context is that while we probably don't think about it a lot when we live in cities, because food would still be available at the supermarket, food insecurity is everywhere, including in this great city where we are. And sometimes it's a consequence of things that happen thousands of miles away. And things like drought lead to conflict, displacement. We have issues that sometimes come to our shores many months after an event. I always like to use the example of cacao. I don't know if you remember, you might not have noticed since you don't probably pay attention when you buy your chocolate at the store, but there was a drought last year in West Africa, the greatest source of most of the chocolate that we end up consuming globally, and that led prices to spike. And cacao futures went totally through the roof. The price hasn't been able to go back down, even though it has reduced significantly. But that has consequences for a lot of industry, baking, and happiness around Thanksgiving and Halloween for my sons. And there's economic instability that is associated with it. And so I want to talk about a little bit my motivation and why for this particular work I'm focused on trying to do it in Africa. So we've heard a lot about input, data in, data out, garbage in, garbage out. So for a lot of models and the work that we do, we end up facing huge consequences or huge problems when you're trying to model or map something in a place where there is no labeled data or where there's no training data. So anything mention it, it could be water level. In a lot of places, there are water sensors on the ground, so we're able to predict the water available for huge areas. Think about crop type. So I do a lot of crop type mapping. If I'm trying to create a crop type map with all the embeddings data sets that are coming out, the key ingredient is labeled data. There has to be ground truth. And another dimension to this is that while droughts happen everywhere, the impacts of them are much more severe on the African continent, particularly in the Horn of Africa. In 2023 alone, 32 million people were affected by it. There's an estimated 3 million people that were displaced by droughts. So you see people migrating due to extreme events like these. Another dimension is that most of agriculture in sub-Saharan Africa is rain-fed. So while there are interventions like irrigation that we might take for granted in some places, it's not accessible to majority of smallholders. Billions are lost annually, so we should really care about that because there's a lot of money involved. And a lot of approaches that we have, drought is predictable, but in many cases we find out after it's too late, after you see an anomaly in NDVI, which is the symptom of something that has been unfolding over several weeks. And so in the grand scheme of things, as it relates to a lot of the work that I do within my lab, is we're trying to develop methods and applications to better understand cropland, crop type, crop yield, with a focus on sub-Saharan Africa. And it's much more complex, so I usually say, if you have a really fancy model, show me the results for Rwanda, and then we'll see how good your model is, because it's a very complex geography, clouds, terrain, very small heterogeneous fields. So any data set that exists in the world, zoom into Rwanda, and you start to see some of the problems that are not so obvious in other places. And so drought, in this case, is critical for early warning. We need all these other inputs, but we need to understand the severity and, across really large areas. And it fits within my continuous workflow. So what we're trying to build, this is a project that I'm working on with my PhD student, is we call it root sense, root as in from the root, where we're thinking about water available to the plant, which equals what we will see in terms of vegetation condition 2 weeks, 3 weeks later. So if you're trying to understand how NDVI will unfold as it relates to rainfall, you look at rainfall today, will give you an idea what vegetation conditions will be in 2 weeks. But then if you look at the water available to the plant, that even adds a little bit more time. Because think about it, not all rainfall is equal. It might rain, the soil might drain through. You have to think about what the soil type is. In other instances, rainfall doesn't equal water available to crops if you can't irrigate it, if you can't store it. And so what we're trying to do is old technology. We're trying to fuse different data sets, different methods, in order to be able to better map and monitor and track droughts in initially focusing on the Horn of Africa. We're trying to get at from satellite to field level precision. It's very complicated, but it's something that once we have results will be quite interesting to see when we do have some results. So just kind of backtrack is in July, NISA mission was launched. This is one of the first images from NISA. This is L-band radar, meaning we can measure soil moisture up to 10 centimeters below the surface. The problem, however, is in order for you to calibrate and understand what's being measured with NISA as it is on the ground, you need ground truth. So we need soil sensors on the ground. And if you look at the distribution of soil moisture sensors from the International Soil Moisture Sensor group, there are huge gaps in a lot of places, particularly in Africa. And so in anticipation of NISA, which we knew would launch at some point in our lifetime because it had been extended a long time, we, with my student, made a plan, was to try and install ground sensors in countries that are severely impacted by drought, but that do not have any ground sensors planned in the next few years. So we installed, right now we have 3 installed in Uganda, Kenya, and Tanzania. They're very little, a drop in the ocean, but there are something, and it's something that we want to build to, to do much more with. The idea is with soil moisture, this is an example of some results, where you can predict what NDVI will be 2 weeks and 2 months later. So we're trying to work with existing soil moisture data from SMAP, train an algorithm to predict what NDVI will be in the future. The idea is the better soil moisture data we'll get, the better the model will be at predicting. That means we can give you early warning of where things will totally fail, which means you could actually intervene and maybe irrigate if you have the infrastructure or not. It has advantages for optimization, et cetera. And these are our sensors that are on the ground, purely with partners. We don't have any funding to do this work, so it's a lot of blood, sweat, love, and care. We have a sensor in Karamoja, where I did my PhD, in Tanzania, and we have one in Kenya at my friend's farm that has irrigation. But we now have entire seasonality for Morogoro in Tanzania because it was the earliest one we installed. We have near real-time soil moisture. I can tell you what the temperature is. I can tell you the amount of water that is available in this particular plot. We're focusing on agriculture, so we can actually create data sets that are relevant for agriculture. This is just sort of a comparison, the advantage that we get from having soil moisture versus using just vegetation indices. We're trying to fuse and get the value from all of these data sets, which is where GeoAI comes in, being able to understand the relationship in context of NDVI of a crop field next to a forest, a crop field next to a swamp, et cetera, to be able to predict properly for those different contexts. That was my last slide, because I absolutely believe I went over, but here for questions.
Thank you so much, Catherine. Next up, we have Hutch Ingold, and he's the technology lead at Earth Genome, where he leads development of systems using AI and remote sensing data to make the world a better place. Previously with Planet Labs, Boundless Geo, and others, Hutch has a history of developing open standards and software for the geospatial domain. He's an experienced technology leader and a strong track record of delivering innovative solutions in geospatial data. Hutch, please share with us.
All right. Well, first of all, thanks for having me here. This is a great group. I'm very, very excited to be part of this panel, especially. So, my name's Hutch Ingold, like you said, and I am with an organization called the Earth Genome. Earth Genome is a nonprofit, and so I've heard a lot of things earlier today about similar technologies and similar things that that others have done here in a commercial space. And I've also heard a lot about economic motivation and incentives and things, and I think it's all very apropos, and it's very interesting when you sort of flip that into a nonprofit world and start talking about impact as you know, profit, right? But so we're a nonprofit. We work at the sort of intersection of what I would call science and the environment, and roughly speaking, that looks like a lot of remote sensing data, a lot of geospatial, and a lot of different problems on the Earth. There are lots of things to solve, and you know, we try to do a really good job in a few spots. So what you see here is a small selection of some of our projects. Climate Trace, which is they just actually at COP just a little while ago, they released a lot more data. Amazon Mining Watch, likewise, tracking gold mining in the Amazon specifically, which is, I think, very interesting. I was looking and I saw about 50% of the poster boards here mention gold mining as illegal gold mining as an active issue that has environmental problems, and definitely something we're seeing expand. We have Plotline, which also deals with a lot of food network issues and sourcing and supply chain. Groundwater, Plastics Watch, again, very similar to Amazon Mining Watch, building bespoke models to find problems, to find a specific problem in remote sensing data. And then Earth Index, which is really what I'm going to get into in a second here, which is sort of an outflow from some of these other projects. So when we were doing Amazon Mining Watch and doing Global Plastics Watch, we followed a very traditional, what I would call, machine learning approach, right? We have remote sensing data, we have positive, negative points, we do a lot of training, we iterate, we try to get those F1 scores up, we try to get, you know, everything to work really well. And in the case of Amazon Mining Watch, we had a lot of success, we published some good results, we were working with indigenous groups on the ground, and one of those groups came to us and they said, well, this is great, we can see all these mines, we can see the change over time, it's wonderful. What about airfields? Because airfields are a leading indicator of where gold mining is going to happen, because you have to fly people in, they clear a little spot in the jungle, and they have to fly the gold out, right? And we said, well, that's great. I have a screenshot of the GitHub issue request that somebody put in that says, you know, can we use this model for airfields? No, you can't really. I mean, you could, right? You have a green jungle and you're looking for things that aren't green, and it's a relatively easy machine learning question, but really the answer is no. And that was really indicative of this bigger issue and efficiency in the way that we were developing models and the way that we were tackling these issues. And at the same time, there was this evolution coming out of the machine learning space around foundation models, and thinking about how we could maybe reinvent some of these watch applications, and how do we find things with foundation models, and specifically embeddings. And so out of that, Earth Index was born. And so Earth Index is a whole platform that we've built using several petabytes of Sentinel-2 data, crunched all of that down into many terabytes of embeddings, and published a global searchable data set of about 3.5 billion overlapping embeddings at about a 320-meter grid coverage globally. And the idea there is that we don't always know what problems people are going to bring to us. We don't know if they're looking for mining one day and airstrips the next. We don't know if they're looking for other issues. We don't know if it's a positive thing they're looking for, a negative thing they're looking for. But what we wanted to do was figure out a way that we could enable people who don't have access. I heard, speaking again about economics, I heard of the barriers to entry of remote sensing. People that don't have access to this type of data, they don't have access to the compute, they don't have access to the money, frankly, that it costs to process this type of data. How can we get this prepared and made available to those that otherwise wouldn't have access to it? So this is all available. It's not behind a paywall, but behind a wait list for nonprofits, but available and online all the time. And so what people can do is they can come and they can define what they're looking for, bring their local context. I've heard a lot of people are talking about machine learning models starting to have text classifications or labels built into the embeddings themselves, which is great. But in a lot of cases, there isn't a word for what you're looking for. You're looking for something that hasn't been defined yet. You're looking for a problem that's new. How do you identify that? How do you apply what you know is a problem? This is the issue. I can point to it. I don't have a word for it. But I can point to it and I can say, this is what I want to find. And so using your local knowledge and the local context that people from around the world have, they can come into this application, they can identify a few points, they can load reference data, and they can start to build up a label of just a few things that are saying, these are the things I'm looking for. It looks like these other things, but I don't want these other things. These are the positives, these are the negatives. There we go. And then what we've built is a way to search these embeddings at global scale in web time. And so what we can do with just a few examples is we build up a representative embedding from essentially averaging the positives and subtracting out the negatives, and being able to search over regional, statewide, even countrywide areas in under a second. And what that'll do is, using that similarity search, that'll give us a bunch of points back, and it's a distance equation, essentially, so that in multi-dimensional space, these things are very close to each other. It was like I forget the gentleman earlier was talking about airports, how airports are very similar to each other, very close to each other in a semantic context, right? Even if they're not geographically close. Same thing here. So we're finding things that are very similar, and then you can iterate through here. You can validate the results. You can quickly mark yes, no, this is what I'm looking for, this isn't what I'm looking for. And then when the time's right, we have a deep search, right? And so we can then do a fully exhaustive search over every single patch that we have in your area of interest, technically in the world, and run that in parallel over all of these embeddings using the model that you built without even knowing it, right? You labeled these points, you used your reference data, you built up your data. In the background, we're building a model on top of that to classify these embeddings. So very quickly, I did these screenshots the other day, and these are chicken farms in the Delmarva Peninsula. I don't know if anybody's driven out to like Ocean City or something, but there are tons of chicken farms everywhere, and they're very easy to spot, and they make a really good demo because they're very obvious. But you can see how quickly this was literally 5 minutes, and they generated a data set that was then able to be exported and published with a very, very low level of effort. So we also are able to then take this information and publish it both into a sort of AI-generated narrative, but then also the data itself, right? So very quickly, we don't want to lock people into a platform, but we want to let people use a lot of data to create more data, and then they own it, and they have it, and they can tell other people about it. So in a nutshell, that's what we're doing. Our results, I think, are pretty, I'm happy with them. I can sleep at night, which is it's really all I ask for. But yeah, so we're still building. We're still adding more data. We're moving ahead. If anybody wants to talk to me about getting access or participating or helping out in any way, happy to talk, but thank you.
Thank you, Hutch. Last but not least, we have Robert Cardillo, who is the Chief Strategist and Chairman at Planet Federal and is responsible for supporting strategic decision-making for future products and services, driving meaningful partnerships, and increasing the utility of commercial innovations for global government agencies. She has had a distinguished career, was the director of the National Geospatial Intelligence Agency from 2014 to 2019. Prior to that, he was in positions of the chairman of the Joint Chiefs of Staff and the Defense Intelligence Agency, and routinely gave briefings to President Obama and Vice President Biden while they were in office. So over to you, Robert.
Thank you very much. I'm going to stay here. I have no slides. Thank you all for enriching the audience. But there's another reason, I think, for me to go in this position of our presentation. But before I do, to Marie and to Chris and to John, thank you again for bringing us together. I'll finish here with another big thank you to you in the room. I've got a long-term connection to this conversation that happens here, and I'm very appreciative of what happened. Second thing you should think of is, if you recall in your younger days, often you could come across a picture and you were going to be challenged, what doesn't fit, right? Okay, so here you go. I don't fit in this group in the following sense. I'm going to come back to tell you why I do fit, but what I don't fit in is you've just heard from 3 amazing humans who are actually making our world a better place. And I just can't thank you all enough for pursuing that and for making a difference. And by the way, thank you all here. I know what the motivation of this conference is, and I've like I said, been a participant, but also a fan. But what I want to walk you through, perhaps as a way to contextualize what you just heard, these instances of advancement and understanding to make pieces and parts of our human existence better, whether it's through crop maintenance and development and reducing food security, to better understanding of living conditions and improving those, to better understanding how we could apply those to advance our general well-being. So I can say proudly, I'm in my 5th decade of being around this profession. I now live in this chapter, but I go back far enough in my government service to recall when, one, this conference wouldn't happen for a couple reasons. Or if it happened, it would have been with a much better, different baseline of data sets and sources. Because when I got introduced to the business, I was given a badge. I don't have mine on here, and it said top secret clearance on it. And thus, what that put me into behind 2 or 3 doors in a windowless basement in a building with very low light, because we had light tables that we would scroll film across and peer through microscopes to look at what? Top secret imagery that came from top secret satellites that could answer top secret questions to people that were allowed to hear top secret answers. Right? Now, this was Ronald Reagan's first term. I'm that old. It was what turned out to be the culminating period of our Cold War with the Soviet Union. So there was a reason for all that top secretness that I just described. It was part of the competition. Imagery wasn't being used. I mean, it was being used, don't get me wrong, but with different sensors, and God bless our Landsat program and aerial collection and ground-based collection, but it wasn't being used the way it is today. And I just give you that kind of anchor point in my career, just to better appreciate the difference that we can now make. But then as I moved through my career, and around the turn of the century, I became introduced to what we now know as our commercial imagery partners. And as was mentioned in my introduction, I am the chair of Planet Federal, subsidiary within Planet Labs, public benefit corporation. And in that job, I work with Planet to help do 2 things. One, to provide access to imagery to my panelists and to this audience, and to work with both government and commercial partners to advance the science and the applications in ways that make the world a better place, whether we're talking about sustainability broadly here today or security. And the last segment of my federal career, I was the 6th director of the National Geospatial Intelligence Agency. And while I grew up in the agency and spent a lot of time in different management positions, I had been away for about 10 years, and a couple of other assignments. And I came back to the agency with a worry. I mean, excitement at being selected to be the director, but a worry that our pride, which I shared in the way things worked yesterday, would not work as well tomorrow. And the biggest challenge I saw was one of mindset, that if we couldn't find a way to better collaborate and cooperate with rooms like this, that it wasn't going to be just to your disadvantage because you wouldn't have access to government experts and systems and sensors and data sets, as we discussed earlier, but the government would lose too, because quite frankly, we wouldn't then be able to benefit from what you all contribute. So I tried hard to open up the agency in a way that I thought would be mutually beneficial. Made some progress there. And again, through this conference, I think some of that progress was well earned. But I still, and now that I've been away from government or in this new chapter for 5 or 6 years, I'm still frustrated, maybe more so in some ways, because when you're inside the beast, right, it's a little bit to understand exactly how difficult you are. When you're outside and then you're trying to work back inside, you go, oh my goodness, how difficult are we to work with? Now, that's good and bad, right? What where you stand depends where you sit and all those things. But I will say, I think the government is continuing to try to find new models of partnership with groups like this. I guess what I'd ask as we turn to some Q&A here with this panel, please continue to challenge whether it's common wisdom or historic norm or especially we've never done this before, response. I believe strongly, especially, and I'll finish here, in a world that's growing harder and harder for us to find commonality, and that's just a human existence kind of observation, where facts aren't facts anymore, right? What's real isn't real anymore, whether it's fake news or deep fake or both. It's adding to the confusion where it needs to be helping. And I know this room is committed to that. I'm preaching to the choir, but the more that we can try to elevate, and I won't be so naive to say that we'll all get to some, equal view and common understanding, and we'll start humming together. But if we could just reduce some of that noise, if we could just raise some of the common, and again, not common understanding, much less common truth, but common perspective, so that we can have the debate about how do we best serve those communities in the underserved ones that you're mapping, and how do we best feed that population? And I would just encourage us to keep our eyes and brains focused on that, and just know that I'll continue to partner with each of you to help do that. So let me close there, and Alex, I guess we can turn over to Q&A, or
I'd like to invite anyone in the audience to get up if you'd like to, and stand behind one of the mics, and we'll take some questions from there as well. But maybe to kick things off, Catherine, Ryan, maybe as well, Hutch, to what degree are smartphones being incorporated in either ground truth collection, data collection, or validation of model outputs? You talked a bit, Ryan, about the importance of co-production with communities and how communities need to feel comfortable with the resulting data that you're producing. So I'll open up with that.
I mean, we use smartphones, for point data. The thing, and we've also started using Street View and so forth. One of the big things we've been trying to figure out is a good indicator of a deprived area is how much trash is in the area. And so we went and visited a slum in Lagos, Nigeria, And what you found was the people who were living above them were just taking their trash and putting it on top of them. And they would just move the trash. And then when we went to the houses, they actually had built in the lagoon on top of the trash. They piled up the trash and built the house that they were living in on top of it. And so one of the things we've started to look at is, as an indicator, instead of looking from satellites, because we have a hard time picking up trash in the streets, is if you go to Street View and other like, land-based things, is, how much trash is there in the neighborhood? Because usually the higher income people can get that moved out of there. They can pay somebody a few dollars to move that trash and put it on somebody else. And it's only the poor people who can't move that trash away. And so these are the things that we start to think about. The hard part is coverage. It's you try to map an entire city like Lagos, Nigeria. It is a big city. And you realize just how massive it is, and how do you start to make sure you have complete coverage of that data set. And so, you can get the points, but then how do you, interpolate in between those points that you don't have, especially if you don't have data that you can use to make a prediction somewhere. And so that's kind of how we've been using it and kind of the struggles we see with it.
Right, thanks.
For my work, so I have a lot of field photos from collecting ground data from everywhere. I like ODK. It's open source. You can use it to collect data. I've created forms from English, French, to Bambara, to Swahili, and I work with extension agents everywhere who, we kind of go through the form and what the motivation. The question can be as simple as how many crops are in this field, or what's the density of the dominant crop, the dominant crop. So we might think about percentages, but it doesn't work that way. So we kind of go through these, and then we got pretty good data across many different countries, but it's so expensive so there are two things with agriculture. One, crops grow at a certain time, so you don't collect data all the time. Crops grow sequentially. You need to collect data continuously. In order to combine that with satellite data, seasonally, if you get an idea of what the crop is, you can model better. So you want to go back. So you have to go back, and then you have to collect a representative set. And if there's a lot of heterogeneity, then you need to collect a lot of things. So it becomes really expensive really, really quickly. But it's a good way to kind of connect with people, why you're collecting data and why they might end up on the platform and why it's important for the ministry to have information, et cetera. So you learn a lot from that process. But then to scale that up and make it deployable across really large areas becomes quickly complicated. And a project that I worked on, if you've ever watched anything I've ever talked about, I talk about it all the time. We call it helmets labeling crops, and basically just imagine your motorcycle and your car. You saw the GoPro yesterday from the video, so we use GoPros, but in this case we're wearing them, take pictures, and we're using a computer vision workflow where we try to detect what crops are. So it's Google Street View for crops. And what that means is anybody can collect data, and we can cover really, really large areas. However, there's still the part where you have to go back. And then now we have millions of images that need to be processed, and it gets even much more complex. But it's a really interesting way to not only create a way to validate data, but also to work with people on the ground to make it useful. Yeah.
Great. I see John hovering in the wings here. So, but maybe I'll just make a point that I think bears. So, Ryan, you spoke about the accuracy of data and how important it is. I'm sure you could speak volumes about that, and maybe we don't have time for that right now. But another, we've been talking a lot about the data torrent in a sense, the amount of data that's available. But I think some people in this room may not really be aware that many censuses in developing countries now are suffering something like 50% undercounts. This is partly a post-COVID phenomena, partly a trust of government phenomena, partly just it's very expensive to run censuses and a funding phenomena. But I think it's something for those of us building these wonderful models to be aware that not everything can be sensed from satellite sensors, and that we do actually need to go out on the ground sometimes to collect data. I do appreciate this panel for bringing forward a number of humanitarian, food-related, food security, gold mining and the impacts and environmental impacts, deforestation and land cover change. These are really, and of course slum mapping, these are really critical applications. So I want to just give one last round of applause for our panel.
Thank you, Alex, Robert, Ryan, Tom, and Catherine. That was great.